So good afternoon, everyone. I'm going to present an EvoCraft, which is an API on Minecraft as a proposition for a new open-endedness challenge. So we can observe from our experience that nature and natural evolution shows this very large biodiversity. And we...
Antonio, close your microphone.
Oh, sorry.
Are we okay? Okay. All right.
Yeah, continue. Sorry.
So we can observe that nature has these seemingly infinite design capabilities. We are often surprised by the forms and the behaviors and colors that natural world can come up with. And we have this idea of we say that nature is open-ended. It surprises us and has very vague fitness definitions and yeah. So this is something that we would like to achieve if we're going to use evolutionary computation as a way of coming up with new technologies and new designs. So we have this idea of open-endedness, and it's a relatively vague term that people had struggled defining. Nevertheless, Stanley and Soros in 2014 came up with these 4 conditions that an algorithm or a system has to fulfill in order to be considered open-ended. So it needs to have some criteria to fulfill. So there needs to be some notion of fitness, minimum notion of fitness. Evolution needs to create new novel opportunities to satisfy these minimal criteria, and the way that these individuals interact and needs to be decided by the system itself. So it needs to be an emergent property. So we are trying to give as many ways for certain properties to emerge within these artificial systems. And condition 4 is potential size and complexity of these individuals' phenotypes should be in principle unbounded. For me, this is like the minimum. If there is one minimum criterion would be this, that the phenotype possibility should be unbounded. Of course, this is not set in stone because there are like some opposing views. There is even this year, there was a paper from Gregor and Besse that took 2 conditions from the previous slide and added 2 new conditions. One specifically that I like is that there should be no notion of an individual. So there should be the concept of an individual should be an emergent property of the system. So we see that, you know, like people are still struggling with the conceptualizing what open-endedness means, but we kind of know we know it intuitively when we see it happening. So there have been some attempts in the past of coming up with an environment. So coming up with an environment is the first step for allowing even to start the research on that topic. So we see that most of work has been done before 2010. So the capabilities computational capabilities were limited at that point, but still people tried. So Chromaria 2014 is the paper where I took the 4 conditions for open-endedness, but more recent one is neural MMO, where the researchers were trying to make an environment where behaviors will be emergent. So this is a massive multi-agent system that you know agents have to come up with goals in order to agents need to come up with some cooperative methods in order to solve goals. And we thought that Minecraft might be a good way of presenting an environment where this type of research might be conducted. For you that don't know, Minecraft is a voxel-based environment that has like basic building blocks. like wood, stone, and if you go, it's a very popular topic on YouTube. So if you go, people do like really crazy things within Minecraft. And also it allows for moving things, and there are certain types of blocks that have signal propagation properties. So these types of blocks allow us to see, for example, fully functioning word processors, giant robots that are capable of moving. We can see implementations of processors in Minecraft, implementation of working neural networks that can recognize digits. And so we thought that it might be a good environment where people can play with the idea of open-endedness. Unfortunately, Minecraft out of the box needs to be interacted with by a player. So we thought of implementing an API. So we implemented an API with 3 basic message interface functions: spawn blocks, read cube, and fill cube. So these allow us to programmatically interact with Minecraft. So spawn blocks just sends a bunch of blocks into the environment, spawns them there. We can read certain defined areas from Minecraft and into our program, and we can just fill cube, for example, if we need to delete things. So this is like version 1 of this EvoCraft API that we thought it might help community to interact with Minecraft. So an example from ideally this is implemented in Google RPC. So we have Python interface, but generally nothing stops us from generating interfaces for other programming languages. This piece of code generates this flyer. So the movement is within Minecraft. We just spawn these blocks. We tested few applications of this API. So this is an interactive evolution where a user interactively chooses which type of, so this is like a cooperative evolution with a user choosing forms to be evolved. We have an automatic evolution here. A tower is trying to grow toward this golden block. So this is a very simple fitness function where we measure how far the structure is from the golden block. We use our API to able to read and write these blocks. And our most recent work is in implementing a cellular automaton that can build structures within Minecraft. So not only static objects like this tree and this apartment building, but also moving artifacts like this caterpillar at the bottom. There are also some other interesting things like a cathedral that is being built by a cellular automaton. We can send hundreds of blocks in one message that can be spawned immediately. So this is just it's slow here because the cellular automaton is trying to build it. So you can find this paper on this address if you're interested in this work more. And we are working on version 2 that will allow entity management. So entities are more like functional objects in Minecraft, which is like mobs. These are like these NPC objects, boats, and certain things. It might help with interactivity and complexity of systems within Minecraft. And we are hoping to get also mobs AI modding such that we can get complex behavior out of NPCs and also Minecraft environment orchestration, which means that if you're running an evolutionary algorithm, you can spawn 15, 20 worlds and then run evolution in parallel. And we are running on the next Gecko conference, we are running an open-endedness challenge. We have prizes, and there is a panel of juries to judge your open-ended algorithm using in Minecraft. So you can find the API and the mod on these addresses, and evocraft.life is landing page for the challenge, and you can find all relevant information there. So thank you for your attention.